Mm, Good morning, everyone. So today we will discuss about Gauss law. Okay, Gauss proposed the one law for relation between the electric flux, and charge associated with flux. So what is the statement of Gauss law? So Gauss law says that this electric flux associated with any closed surface which is given by sum of your total charge divided by epsilon naught. It is electric permittivity of medium. Now this is your Gauss statement. So we revise what is the flux. We know electric flux is given by electric flux phi is given by electric field associated with any area. It is dot product of electric field and area vector. So which is result into E a cos theta. Cos theta, it is angle between electric field vector and area vector. Now what Gauss law suggests, like if you have any charge particle q here, and if someone asks what is the electric flux associated with at distance r and some imaginary surface, let's say spherical surface. So what is flux associated with this surface? What is flux associated with this surface? So according to Gauss law, E dot ds is equal to total charge inside this surface divided by epsilon naught. Now E dot ds, as we know, the point charge has a direction of the electric field radially outward, right? And this surface vector also have a vector, surface vector, it is radially outward. So theta is equal to 0. So it is E dot ds. This is your flux associated with closed surface. So what is the inside this surface, the charge? Inside the surface charge, total charge is q by epsilon naught. Okay, and what is E? This is your total flux. If someone asks what is the electric field at that point r, so now this all distance are equal distance from your point charge, so electric field is constant, so electric field come out from the integration, so E and this close integration q by epsilon naught. So what is this close integration? It is the surface integration. So what is the surface area of this sphere? It is E dot 4 pi r square is equal to q by epsilon naught. So this electric field is given by q by 4 pi epsilon r square and in the direction of r cap. So which is same as your Coulomb's law. Okay, so it is verification of your Gauss law, which is correct because it give a same rule as given by the Coulomb's. This is your vector. Okay, now first we will case some different cases. Like if you have given some surface and inside this there are charge, let's say 3q minus q plus q, and here is 4q. If someone asks what is the electric flux associated with this surface, then flux phi is given by sum of your total charge divided by epsilon naught, this enclosed, let's say enclosed means this charge enclosed by your Gaussian surface. So in our case we have asked you what is flux associated with this surface. So total charge is 3q plus q minus q divided by epsilon naught. So flux associated with this surface is 4q minus q. So it is 3q by epsilon naught. So this is your electric flux associated with this surface. Now if you have one question, right, this is your conducting shell and it has a charge on the conducting shell is capital Q. Now you have asked what is the electric field inside the shell and electric field outside the shell. So let's say radius of this shell is r. Now let's assume, suppose Gauss law give you E dot ds is equal to enclosed charge divided by epsilon naught. So now you assume one Gaussian surface, like for inside you have to take Gaussian surface inside the shell. Okay, so let us say this is your Gaussian surface which is inside your shell, spherical shell of radius, let's say small r, and this radius let's say it is capital R. Now the spherical surface with radius small r, for that E dot ds is equal to q enclose divided by epsilon naught. Let's say enclose. Now as we know the electric field, it is perpendicular to your surface now, so it is E dot ds is equal to 4 pi r square. But what is the total charge enclosed in this surface? The total charge enclosed in surface is, there is no charge at the center of the shell, so r is equal to 0. Q is equal to 0. So it is 0. So E is equal to also 0. So electric field inside your spherical conducting shell is 0. So E is equal to 0 here. But as you go, the radial distance r greater than capital R. So what happened now? Okay, so this is your spherical shell of radius capital R. Capital R. Okay, now we have to find electric field at r greater than r distance. So now this is your radial distance, and now imagine one Gaussian surface at that distance. Okay, so this is your spherical Gaussian surface now, and this charge on the spherical shell is capital Q as mentioned in previously. So now what is the electric field at point r greater than r? Now according to Gauss law, E dot ds is equal to q by epsilon naught. Now E, we have to find what is ds. This is surface area of this bigger Gaussian surface. So Gaussian surface area is 4 pi r square is equal to, and enclosed charge, the enclosed charge is charge on this surface. So what is total charge on this surface? It is capital Q. So it is capital Q divided by epsilon naught. So what is your electric field? Electric field E is equal to Q by 4 pi r square epsilon naught. So what we are getting? So electric field is vary as r square, where r is greater than your radius of your shell, and inside the shell E is equal to 0. Now if you have asked plot the curve between E and R for spherical shell. Okay, so let's check here. If you are given one shell, now you have to plot curve for a electric field versus distance r. Okay, in y-axis, let's say it's electric field, and x-axis it is r. Your y-axis pass through the center of your shell. Now here, as you go from center of the shell to distance r, the electric field inside the shell is 0, so E is equal to 0. So your plot is look like this. At just outside of the surface, your electric field E is equal to 1 upon 4 pi epsilon naught 1 by q by r square, right? And q is your capital Q, so it is decreasing as a r square. So this look like that. So this is your plot E versus R for spherical shell. Okay, so thank you.